So first, we need to log in. But I will not be showing that part because it's my own credentials. You might change it to something sus. Anyways, after logging in, you will see the dashboard. Then you can see the create button. And we select the circuits. There's a ton of choices, but hey, we'll be creating circuits. In the components, we will choose Arduino of course, because that is what we'll be needing. Then you can see there's a lot of Arduinos, but since we are beginners, we will start with the basic Arduino and breadboard. As you can see, the power and ground is already connected to the breadboard. To mention, it already has a code block in which we will be using for the activity blinking LED. So to locate, we can go here in the code. After that, we click the drop down button and select the text. Of course, we want to locate the code. There will be a prompt, but just continue. Just like life, we have to continue even though someone or something may block us. Going back, now you can see the code. And here we can see the simulation. In here you can see the onboard LED is blinking. Whoa! But our main goal is to add it to an LED. So we close it and locate the needed stuffs like the LED and resistors. First, we attach the resistors so our LED doesn't go boogsh boom. You know what I mean? LED of course because where will we have the lights? On a resistor? And of course, we need it to connect in the Arduino because what will be the brain of it? To mention, we will be connecting it in pin 13 that is directly connected to built-in LED. And when we simulate, here's the result. You can modify the code to make it faster, like disco. Or like an old bulb that needs to be replaced. The first one on the code is for going high, like lighting up the bulb. And the second one is for the low, in which is the delay, or it's going off. I will test it to see the difference. I will put a different values on it.
So to start a new project with ESP32 with MicroPython chip on it, let's find the MicroPython. And then in here, you're going to select new project. Then select MicroPython on ESP32. So now we have our starting development kit. So first is to add an LCD I2C. So to add a new part, please click this plus button and search for I2C. Then the first connection we're going to do is to connect the ESP32 GPIO22 to SCL of the LCD. We're going to find the 22, then make it to the SCL of the LCD. So the next part is to connect the GPIO21 to SDA of the LCD. SDA U21. Then the next part is to connect the ESP32 voltage input pin to LCD VCC. Just this. Then connect it to VCC. And the next part now is to connect the ESP32 ground pin, the ground of the LCD. So this is the ground pin of the ESP32 and then connect it to the ground pin of the LCD. So the next thing we're going to do is to add the PIR sensor. So the first step is to connect the 3.3 voltage pin of ESP32 to power leg of the PIR sensor. So first, we need the actual PIR sensor. Then we're going to connect the 3.3 volts to the power leg of the PIR sensor, which is the positive part of the pins. And then the next step is to connect the ground pin of ESP32 to ground leg of the PIR sensor. So ground pin, then ground pin of the PIR sensor. So the last pin is going to be the connection of GPIO 14 to out leg of the PIR sensor. So first we need to find the 14 in the ESP32, then going to connect it to the middle pin, the PIR sensor. So for the buzzer connection, let's try to add the buzzer component first. And then the first connection will be the ground pin of the ESP32 to ground leg of the buzzer. So this is the ground pin of the ESP32, and we're just going to connect it to the ground pin of the buzzer. And then the second part is to connect the GPIO 23 of the ESP32 to the positive leg of the buzzer. Then connect it to the positive pin of the buzzer. Fine. So the next one would be adding the LED. So let's try to add the LED first. And we're going to need a resistor between the connection of the ESP32 and the LED to avoid frying the actual components. So let's try to add 1K resistor first. So the first step will be to connect 1K ohm resistor between the GPIO 12 of the ESP32 to the positive part of the LED, which is the longer wire in this LED. GPIO 12, then wait, I'm going to align this first so it looks cleaner. ESP32, then connect it to the positive part of the LED. And then the next one will be connect ground pin of the ESP32 to ground leg of the LED. So this is the ground leg of the ESP32, and you're just going to connect it to the ground pin of the LED. So the next part is going to be the actual programming. So we're going to paste some code in the main.py. Then the next part will be adding an LCD API.py. So LCD underscore API.py. Then paste some codes in it. Then the next part would be add I2C LCD.py. I2C LCD.py. Then the last part will be the adding of the picopassive buzzer.py. Picopassive buzzer.py. So let's try to test our circuit. Start the simulation. As we can see, there's no motion yet, so the buzzer is not making a sound and the LED is not lighting up. And the LCD also states that there is no motion detected and the area is safe. So let's start to simulate a motion in the PIR motion sensor. So simulate. And then as we simulated a motion in this PIR, the buzzer sounded off and then the LED turned on, and we saw that there's an intruder in the LCD. So for the finishing touches, let's try to change the wire color of the wires that are connected to the voltage input to red, so we can determine properly which wires are connected to the other pins. And that's it. And thank you for watching.